speaker is Julia Stakowski, and from this school, Julia is a student I've had in a class I gave on network science that was meant to be only for computer sciences, but she managed to successfully do that course, and we have interacted since then. Legacy systems and security is what she will be talking about, and I don't want to take too much of the time and let you, right.
Thanks so much, Justin. Yeah. Right. So I'm Julia. I'm a PhD candidate in information systems. Do we have any IS people here? We all see us hands. Hey, there we go. I didn't think we'd have anybody. So for those of you that don't know, we're kind of like more social sciencey. We study things like human behavior and technology and kind of the business applications. We're also the place where your freshman college roommate failed discrete math goes after they decide to change their major. So depending on how you're doing that course, it might seem database management in the fall. So today we're going to be talking about legacy systems. So I think it's fair that we start with what is the definition of legacy systems. Now, my dissertation has about 30 pages on this question, and I'm going to very simply just go with formerly adequate, now obsolete technology that is still in use. So this is hiding a lot of nuance, but it is the most common definition of the software engineering literature. Since we mostly have computer science folks here, I think it will be a good operational definition for us to use. So not everybody agrees on this definition, but it will be the one that we use today. So any technology that at one point in an organization was meeting their requirements and has now become obsolete as technology has advanced. Your second question might be, are you making us learn about old computers in the context of a workshop on cutting edge research? I'm not sure why you said the rest of that stuff to me because that's not very nice. The reason why is because many of these systems you will support in an organization are legacy systems or will at some point become legacy systems. Unless you're working for like a startup where you're building your entire tech stack from scratch, you're going to be working with technology that's already been implemented. Additionally, systems don't go away just because they are old. You actually have to do something about it. And systems are not bad just because they are old either. There's a reason why the system has been in the organization as long as it has been. So you can't just dismiss these systems like, well, they're old and I want to work on something new. It is your job to work on these systems because they're critical for the day-to-day business operations. So you can't just go to management and be like, well, we're not going to use the system because it's old and outdated. It is your job as a member of that organization to actually maintain that system and secure it. Also, despite your best efforts, you will be the people that write the next generation of legacy systems. So you can future-proof a system to some extent, but eventually they all become legacy systems after implementation. So it's good to understand what you're doing. I come from the social sciences side, so I want to start talking about some of the management organizational issues that we have with legacy systems. And then we're going to shift to talking about the technical issues. And then I'm going to stop yammering and give you like a case study to look at. So first, main thing that from a business perspective matters is the cost. Maintenance of these systems is very expensive. And also you have to think about what your market competition is doing. That startup is able to adopt the newer technologies easier than the person that implemented their systems decades ago. So what your competitors in industry are doing matters a lot here. Also, a lot of these systems do not have documentation. This has gotten better with time because the modern legacy systems are often the ones that we wrote like 20 years ago instead of like 60 years ago. So usually better code commenting practices, but it's still a major issue. You're kind of relying on a bunch of like people that worked at your company for a long time that remember things but didn't actually write them down. Speaking of those people, staffing is very difficult. If your legacy system is built on like an old tech stack that nobody's specializing in anymore, the people that still are in the market are able to demand a premium for their services because they are the only ones that know how to write that programming language. And eventually you're going to run out of people to hire. So this is a major issue. And this is more of like a signal to you that maybe you have a legacy system. If your vendor is dropping support for the system, it might be time to move on. But losing that vendor support, you no longer have somebody to call when it collapses. Having the support is very important in organizations where you need near 100% uptime of your system. Another one is compliance and regulation. I ran into this one all the time when I used to do software engineering for a legacy system. Oftentimes, we would have like new government regulations on financial reporting, and we would have to go through all the different systems that have that data and build new interfaces to get that data for the government. This was especially complicated in the context of like an international system, where we had to look at like tax laws across jurisdictions. And if you're not meeting these requirements as an organization, your business could be shut down. So again, it's a huge issue. User satisfaction is kind of a weird one. So at one level, you have users that are they don't like the old system. Like, this is crappy to use, the interface sucks, I hate it. I want to get out of here. On the other hand, your users' perceptions of the system is going to influence all future development. So you might have a user that actually likes the system because it's what they know. They're going to be very resistant to change. On the flip side, you might even have somebody that doesn't like the system, but they're going to judge the new system based on what the old system can do. The most common thing I've seen come up in these kind of like migration scenarios, surveys like, well, this is how we did it in the old system. Or how come the new system can't do this? We need this for our business process. So a lot of what your work is adapting the new system to actually meet those business processes that were formed around the old system. So, and the reason why that matters is you can't just tell the users we're using the system and deal with it. They will actually like just project it. And then business process change is another huge one here. As what you do as a business changes, you need to reflect that in the systems that you've implemented. Are they up to the task of actually meeting those business processes change? An accounting system, the main idea of a general ledger isn't really going to change all that much over time. But for other systems, you might actually have a significant change in the business process, and you might not be able to adapt the system to meet that change. Which gets back to your market competition. If they're able to do that, very This is just a list I came up with from my reading the literature, but if anybody has any other ones they want to shout out, better management related. Just do the next slide. Right. So, technical issues, you might be more familiar with these. Integration interfaces is a huge issue. So these legacy systems often have to be integrated with the new system to implement the organization. The problem is a lot of these systems were built before we knew what an API was, or they might be built from like a flat file system instead of a SQL standard. You're not able to easily integrate those systems together. So oftentimes what you end up doing as an organization is building these interfaces yourself, which is very, very, very cost intensive and labor intensive. This is a security seminar, so it makes sense to talk about security a bit here. Oftentimes these systems are going to be built on old authentication standards, old encryption standards, and they might not actually be able to be patched anymore. Again, this gets back to your vendor support. If your vendor has dropped support for a system, you will not be getting security patches anymore. When you don't get security patches, you have to reevaluate how you handle the system. So you might have to do something like network segmentation, for example, because you can't trust that the system will not be exploited. But where patches are available, you should have them implemented. It's just depending on how old the system is, you might have to system. These systems are often also very fragile. So it's great that we can make changes to the system, but those changes actually take a long time because the system itself is very finicky. So if you, for example, make a change in one code module, it might totally break something in another code module, which isn't unique to legacy systems per se. But a lot of legacy systems, just because they've been implemented for so long, have so much code have so much like technical debt that we've acquired over time are particularly fragile. Data integrity is a huge issue, especially in business systems. If you are getting bad data from your accounting system, that's really horrible, so don't do that. But we also have limited ways to ensure data integrity. A lot of these systems, for example, don't have a proper like testing and tooling interface from regression testing, which is my next point. So not only are you dealing with a fragile system that is critical for your business operations, but you also have limited ability to test that system. So when you make changes to it and you're worried about this fragility, you don't always know entirely that it worked how you hoped it did. So being able to build that testing infrastructure around it is very important. Scalability as well. This could be a constraint of your hardware. So like you just cannot process the amount of information you need to with the hardware you have, but also in your software architecture. Does it actually lend itself well to scaling? Again, going back to the system I worked on, it worked great for like 1,000 employees, but it was really showing an inability to scale up to like an international business with tens of thousands of employees. And then this gets kind of at everything we talked about is the complexity. It is complex to modify these systems, and systems are complex. They're embedded in complex social structures. They're embedded in complex technical structures. Everything that you do in these systems requires a lot of analysis, a lot of careful planning because of that complexity. And then kind of the nightmare scenario is just failing hardware. At some point, these systems embedded in the real world will fail. And oftentimes don't have hardware readily available to replace it with because it's not produced anymore. So on the next slide, I am going to put up a case study. It's what I wrote myself, so it's pretty good. But what I want you to do with it is to identify any management and technical issues. So we're not worried about solutions yet. We're going to talk about that later on. But just thinking about reading the text case, what issues do you see? And I also encourage you to kind of follow like second order effects. If I see this issue, what else might it cause? So it's not weirdly quiet in here. I've made it a group activities for the people next to you. But basically, I'm making you a developer on a legacy system. And it has all these issues which you should identify on a piece of paper, and then we'll talk about it in like 10 minutes. Sound good? Any questions? All right.
Okay. I take Gerald's crap and rewrite it to Rust.
I don't know about that. Self-documenting.
That's my solution for. The rest of the program, the server and whatnot, I could deal with no API if I could just like write a scraper with Python and beautiful soup and whatnot. I can deal with an SQL database that's like anything can interface with SQL. The business logic that's if I ever need to change things, you know, you might as well just rewrite the entire proprietary language.
Yeah. I don't know, Gerald seems to be a good place mentally.
Yeah. Like, you're either going to continue using that program, no change to anything whatsoever other than segregating and everything else, or you're going to rewrite something.
Can you go back to the slide with the list of management issues on it, just for
Yeah,
maybe
for sure.
30 to 60 seconds?
Alternatively, you can lobby Congress and say, hey, every company that goes out of business has to make all of their source code open source. Same for any company that stops supporting a product, they have to make that open source as well.
That'd be kind of fun. I just want to see the code.
Yeah. You're like, if you're not going to work for us, you have no right to having proprietary secrets. Use it or lose it.
Thank you.
Why'd you choose the first three?
I don't know. When I write things for classes, I just sit at my computer and think, I don't know what I'll write, and then it happens. So that's what all my exams look like too. So
So specific.
this semester we followed the story of Harold, who after a divorce with his wife fell down the stairs. They had to replace his arms with yardsticks and large gloves. Like, it's just it's a teaching methodology. Yep. And this isn't an exhaustive list. If you guys see something that pops out, I encourage you to bring it forward. Yep.
So when it says the system is hosted on physical Windows server, what is that saying? Like, is that the address of the company account, or is that?
So
Also is that the person?
yeah, sorry, I should be more clear on that. It's instead of being like hosted on a virtual machine, it's on a physical like server box, and that is where the system lives. The user still access it from like the desktop.
Never.
I'll give you one more minute and then we'll get started with the kind All right, so I've made a whiteboard in Notepad++, so we're gonna go with this. You can pick any of these three categories, but if anybody wants to raise their hand, call out one of these things. Yeah.
And just get warmed up with the security category, the technical categories. Quick Google search shows Windows Server 2003 enterprise was in July 2015. And a keyword search on cve.miter.org for Windows Server 2003 comes back with 818 records. And out of 50 or so, those are from 2015. Wow.
Yep, this is an excellent one to start. So the underlying infrastructure that our application is implemented on has not received security patches since 2015. And obviously, attackers are going to take advantage of that because of businesses like this that still have their infrastructure on Windows Server 2003. So that's probably one of the biggest technical issues we have right now. We'll talk a bit more about solutions later, so let's stick around with issues, but that's a great one to start with. Yeah.
If document the code that paired with the time.
One's here. So not only did the person that wrote the code leave the company, but that person, while they were there, decided not to document the code. And like the case seems a little bit silly, but that happens all the time. This isn't like a crazy out there scenario that we're talking about here. So, next one. Yeah, that. So a lot of the users actually don't even like the system. It is required of them for their jobs in the organization to use the system. But we're going to be dealing with a lot of users that are going to be angry at the IT department all the time because they don't like the system they implemented. It's really hard to get user buy-in on a lot of things when they already kind of feel adversarial towards you because they don't like the system you have.
So because you've got that code written in proprietary language, you may have difficulty in the future getting access to up-to-date versions of compilers or existing compilers at all.
Yep. No, that's an excellent point. I actually worked on a system where the whole system was built in a language called Dexterity, which was used to build a single ERP application in 1992. That was never used again. So this was a major issue for that group. So, yep. Exactly. Really good one. So we have all these issues, but it's also very fragile to any change.
It's hosted on like a physical server, so there's no really backups for like
Yep. So there are definitely, well, I won't say definitely because a lot of organizations are bad with their backup practices, but it should be backed up. But you can't just fire up another VM if your server hardware fails. It's just hard down. It's really great point. What else did y'all see?
It was hard to integrate, hard to integrate the system.
Yep. So since there is no API interface for the system, it's very difficult to integrate the system with the new systems implemented in the organization. The challenge with that is this existing system is critical to our processes. So we probably do need to integrate it with other systems. In my experience, most like systems development is really focused on the system integration part because you're just constantly trying to build connections to other systems to keep it afloat. Yeah. Yep. It's a great one. Classic management problem. So partially because of all these technical issues we have, it is very expensive to maintain the system. It's very expensive to do a system integration project because we have to deeply understand a system that is poorly documented, written in a coding language nobody understands. Well, I guess Gerald might understand it. It's
You're tired, so I'm not.
Yeah, true. You'd have to pay a lot of money for Gerald to stop watching Cars 2 for 30 minutes to come help you, but what else do we have? Yeah.
We have lack of technical support.
Excellent one. I'm actually going to put this one in both sections. It's really a socio-technical issue. It's lack of support in general. So, the company that made the system went bankrupt, which that's usually a bad sign for you receiving support. It's not only are we not receiving support on the business side, we're not receiving like new updates for security issues, and we're not receiving new feature updates either. So, and also really the most terrifying thing you can do in enterprise software is have a critical system running and you don't have anybody to call if you can't figure out the problem. The company is bankrupt, there's nobody you can escalate to. You are the last person to escalate to. So, support contracts are very important in enterprise software, and if the company doesn't exist, you don't have one. So, the other ones. Didn't feel like Cheryl had anything going on, like the different issues. All right. So we've identified quite the list here. The only one that I really want to add on here. So we talked about compliance and regulation. This is an accounting system. We're going to be subject to a lot of tax law changes. So again, that's one that maybe isn't immediately intuitive, but because of the other technical issues with the system, it makes it difficult to actually make those changes.
Along those lines, are there federal laws also regulating standards that come with
It is a mess out there. I'm not entirely sure whether this would be compliant or not, you know, depending on the type of information that's stored in the system. You know, if it's your own accounting data, that's a lot different than if you have a hospital system with patient data in the same scenario. So it could very well be the case that the system does not even meet those standards. Again, when the government's like, hey, you should not do that, you probably shouldn't do that if you'd like to stay in business. So, all right. So we've listed a lot of bad things, but let's talk about some of the things we can do to actually address this. So I'm going to break this into short-term and long-term planning because you should have a plan for both. I think one of the key mistakes that people make when they're talking about this topic is they're just like, oh, well, we should just replace the system. Sure, but that takes a long time. So what are you going to do in your day-to-day operations to make sure the system runs smoothly and is actually secure? So you should always start with updates and patches, assuming that your vendor exists. In this case, we do not have the vendor. But in a lot of cases, you will have an older system that will still be at least receiving some security updates. So you should be able to patch it to some level. Another thing you can do is build middleware systems, meaning instead of you just constantly working with this system directly, you build a system that other systems integrate into, and then that is what talks to the main system. As you might imagine, that increases the complexity of your overall enterprise architecture overall. So you should do this very cautiously. And the real irony is a lot of times the middleware systems eventually become legacy systems. It's just like a chain of sadness, but kind of a very, very strong approach to this. It's just whole network segmentation. So when I used to work in networking, we had a case where we had industrial software that could only run on Windows XP machines. Now, the nice thing about these is they didn't need to talk to anybody else in the organization, and they didn't need to talk to the internet. So we just put them on their own VLAN, virtual LAN, and just did not let any of that network traffic out. That is an example of network segmentation. But this doesn't always work, because if you have a system which everybody needs access to constantly, where you can use to connect to the internet, this is no longer a feasible solution. So all of these solutions really are going to be dependent on your specific scenario, and you have to balance the security trade-offs with your organization trade-offs. If you can do network segmentation, like if it fits, you should go with that, because then you can at least, you know, people can still exploit it if they have physical access to the system like any other system, but you're not putting a Windows XP machine on the internet, which is a bad idea. So other thing that a lot of companies do is virtual machines. So they try to detach the system from the failing hardware or just really old hardware it's on. So this is used all the time for cases where you just need to like run an older operating system. This gets more complicated if you have like specialized hardware that goes with the system, then it's unclear whether you can use a VM. It really depends. I have a Windows 98 screensaver fish that runs on Windows 98 VM, so I use them all the time. Another one, so if we can't guarantee that the system is protected, we can at least have an intrusion detection system around it to be like, well, we know it's got hacked again, so we'll do something about that. As well as configuring your firewall rules. You should have the absolute minimum traffic you need going to the whole system. That's often configured at the firewall level. It might also be configured on like your access switch. Training is another one. So, and this goes for both your users and your developers. From a user perspective, you might have a user that's coming from an organization that's using a modern system, and now they're coming to your organization, they're like, what is this? I don't know what this is. You need to spend the money on training them and make sure they understand how to use it because it is critical to your business operations. Additionally, you can train your developers. So, you know, it really sucks that Gerald decided to write all this code in a proprietary language. But, you know, you can teach your developers how to write that language. That is a huge, huge, huge time investment, potentially even to some cost. But it is a approach. Because again, the system has to run. Somebody needs to understand it. You can talk about how crappy it is that it's written in that language all you want. Somebody has to understand it. So training your developers, and this is really where your people that have been with the organization a long time, making sure that they actually write like formal training, not just like sit behind me for a week and then become an expert kind of training, because they will eventually leave the company. Another approach, this is really getting after user satisfaction issues, is to build a new front end to your business. So you have that old legacy system in the background, but the user doesn't actually know this because you decided to make like a new cool web page interface that just pulls all the data. This one is really going to depend on how much access you have to the data. If you're working with a system that, for example, has everything stored in a proprietary flat file that nobody can actually understand, you can't really build a new interface. But if your system has like a SQL, so SQL background, your backend, you could build a front end for that. Similarly, you can completely wrap the system, and then you really just don't interact with it directly anymore. You're passing everything through a wrapper. Again, not an exhaustive list. These are approaches you can take. Long term, we have a lot less options, unfortunately. You basically have system replacement or migration. So just wholesale removing the system from the organization. But you also have system modernization. Some organizations will choose the replacement if they can, but a lot of organizations are in a place where this software is so custom built to their needs, they really can't feasibly remove it without risking the collapse of their business. You see this with a lot of like banking systems that were built in the 50s. Instead, they take approaches of what can we do to modernize this, acknowledging that there are risks that go with that, but also be like, hey, our banking system collapsed today, so that's pretty cool. And also, this is not an easy process. It requires years of planning and iterative development. Just as an example, this was published in a 2019 Information Systems Research article. This is one MS-DOS system in an organization that they started de-emphasizing in 1993. They did not finish replacement of the system until 2005. And even then, they still had a couple instances where they were still supporting that system. You don't need to worry about all the details here, but you know, this is just a crazy process, takes a lot of time. Don't undersell how much it's going to do this. A lot of IT projects are like, we're always over a budget. It's because they didn't think about everything that goes into it. It's never a smooth process. And it's going to look different for every system. This is just one system. A different system might have a super simple replacement. Another one might be even worse. So
I think I'm starting to understand why a lot of companies just use Java. You can keep using it forever, really.
true. Yeah, no, really, even if it's bad, I don't want to say bad, Java's obviously not inherently bad, but even if it's not the best, if everybody understands how to use it, it's a common way to get that staffing. Sometimes just go with it. All right, so the next part is we're going to talk about a risk mitigation plan. So we talked about the issues last time. Now I want you to, again, using the case text, give me your short-term plan for addressing the issues and your long-term plan. And the key thing here, This is where the IS people are going to shine. All one of us is you need to justify to management why they are necessary. I know it's kind of annoying because you're like it's like about to melt down. We should do something about this. Most managers don't really know everything you know about computers, so you need to be able to communicate to them in their own language why this matters. So I'll give you like 10 minutes to work on that, and then we'll go over it. Would you prefer me to keep the issues we identified up, or would you prefer the case text? How many people for the issues? Case text. I sincerely apologize. You're the only one that raised it. All right. Leave that up, and we'll get started.
Can you see the short term?
Yes. So long term, you basically have replacement and modernization, and then short term, yeah, not an exhaustive list, but some. Middleware systems kind of exist between different systems. So you have the legacy system, and then instead of accessing it directly, you have a middleware system that's handling the system. It integrates systems together.
Yes. No, it's like small stuff that's
Oh, yeah. Yeah.
All right, so let's walk through these. I will play the manager who tends to not know about computers. So when you give me a plan, I will ask you why. So just be prepared for that. So who wants to give me a short-term plan to start?
We need to get our old buddy Gerald back real quick, so he can train up the next generation. And, maybe we have to provide, to get him to come back, and he's already retired, so we might need to set something up with that magician and his ex-wife, maybe.
Yeah,
Get the magician out of the picture for a little bit.
that's a good point. Use the magician to your advantage. So,
Any leverage you got.
yeah, no, this is an excellent point. This doesn't always work because, Gerald is retired and it's not his problem anymore, literally. But usually if you shame people enough, they will show up or to give them enough money. So this would be an expensive option, but probably necessary, at least to have them back for a couple weeks or something to explain to us what each of these things do, and then we'll try our best to work from there. What are your plans? Do you have?
Get that Windows Server 2003 system onto a virtual machine and as far away from any possibility of being connected to the internet as possible, so that we don't have to deal with any sort of security issues in the short term. In the long term, we'd like to replace that, but short term, we're trying to avoid getting ransomware.
Yeah, no, this is an excellent one. So we can't really completely segment this on the network because so many systems in the organization depend on it. But we can at least directly disconnect this from the internet and move it to a VM, which is going to help both security-wise and also cover our tail risk with the actual physical server failing. So, okay. What else did you guys know?
satisfaction.
This is a great one. So instead of replacing the system, which is what the system, you could just be like, well, we'll make it look nice to the end user. You'd be surprised how effective this is, at least of getting users on feedback. Does it address all the fundamental issues we have? Not necessarily, but it does make your users happy, which is non-trivial. So this is a common practice, and even in non-legacy systems, oftentimes, like people don't know how to design a good user interface, and you will go through and adapt one that actually works for your business. And to manage it, you're just like, we'll make the system look nicer and easier for our users to use quickly, or whatever. More effective business operations.
I think another advantage that developing a new front end would allow for updating of like stuff for third parties like Austin Road.
Yeah.
Yeah.
Yeah, that's a good point. And this is actually a pathway that some companies will take is, well, everything around the system is horrible, we need to get away from it. But the core data model is important to our business. So we will rebuild a new front end, not just for the users to be happy, but like kind of an entire overhaul of the system, but we still have that primary. So, which also allows you to like actually enforce when users log in, modern authentication protocols, not just what system shipped with in 2003. Yeah.
Update security, the patches.
So that would be a great first step, except our server infrastructure is no longer supported by Microsoft. And also our application developer has disappeared. They have gone bankrupt. So yes, we should update as much as we can, but in this case, we're actually very limited on what we can do here. But in a case where patches are still available, that would be step one. What else we got? How about for system integration? Since we don't have an API, what would your plan be for that?
Some sort of scraper program. So like I said, Python is beautiful, so it's great for scraper.
Scraper could be an option. We don't know if this is what host that. I didn't post that. But another thing we have here is we do know that we have a SQL database backend. So similar to how we can build a front end on top of that existing database structure, we can also build integrations with the SQL database itself and just bypass the application. Now, there are a lot of risks that go into that because you don't fully understand the internal business logic of how the system is using the database versus how you're using the database. Back when I worked on a legacy system, kind of our approach to it was you would do something in the legacy system while keeping a SQL trace, which is basically like Wireshark for SQL commands, and see everything that it does when you like click a button in the accounting system, for example. And then you can kind of reverse engineer what your integration should be. Again, not perfect, but you have to be careful that you understand that what you did is what the system would have done as well. And hopefully your SQL databases are documented. I worked on a Microsoft database where they just let the community basically be the people that manage the documentation, which is an interesting approach. But at least in the short term, most companies are going to take that approach to integrate with the SQL database. About thinking long term, do you think it's a better option to replace or modernize? How many people would just like try to replace it long term? Right. How many people try to modernize it? let's go with the modernization. Why did you pick that one?
I figured outside of the language itself, once you teach from that point, all those like small changes would eventually kind of, you don't even, okay. You have your own teacher with language, that person that now knows language, you implement all this documentation. And then from there, you just kind of how you know how to update it yourself. It does still run on that one Windows. That's where firewalls come in. Put it onto a virtual machine instead of the physical server. It's essentially all the little steps of replacement without the full cost of it.
Yep, and that's an approach a lot of companies take because it's lower risk in the short term because you're not fully replacing something, you're taking what's already there and augmenting it. How about for the replacement crowd? Anybody want to say why they chose that one? Yeah.
Well, after you release it, you can advertise your company as having a new software platform, and that helps a lot. And sometimes if there's too many things wrong, it gets too complicated trying to have everyone company learn something that was already there but it's changing. So sometimes it's better just to have it and teach how to break something.
Yep. That's a great point, especially if the software is like facing towards your customers, so you can like, be like, hey, we got this cool new system now. But also, what I really like about that point is all those things adding up to make it difficult for you to really manage the system. For me personally, I probably would go with replacement. And the main reason for that is my software vendor doesn't exist anymore. I don't want to be the person that manages the software without some sort of person backing me up, some sort of institution. Again, there was no right answer to that one. Modernization and replacement are both fair responses to that problem. Nice work. So my time is almost up, so I will do some closing thoughts here. So the key takeaways. Legacy systems are in use, so you must have immediate plans for supporting their operations security business assets. If you go to an organization and just say, that's old tech, I don't want to deal with it, you will not have your job for much longer. It is our responsibility to take care of these systems. Legacy systems run our organizations, and most of us work for organizations. Also, as we talked about, no risk mitigation method is perfect. You saw me kind of give a lot of wishy-washy responses. That's because there's really no like solid, do this is correct. You really have to weigh the trade-offs. And you can't just think of the technical problem. You have to think about what is the organizational problem? What is the impact on the organization? We can't just study these technologies detached from their social context. You need to consider the trade-offs. You might, for example, want to like redevelop a whole system. And this actually happened a lot in like the 80s when the systems were of smaller scale and they could easily redevelop the whole thing. But with modern systems, like there's so much going on, it's very difficult to justify that kind of labor-intensive procedure. Also, just like having respect for the systems that came before you. This sounds kind of cheesy, but like the legacy system only persists long enough to become legacy because it's successful. And you will create legacy systems that people complain about at some point in your career. So also like I really love working on legacy systems. Like, I don't know, I call myself like a shit post coder. Like, I just like, most people just like shake their head and they're sad. Like, isn't there a better way to do this? Oftentimes in the legacy system, there's not. Like I wrote a JSON parser in Visual Basic 6.0 that calls like a JavaScript library, parses it, and returns it back as a VBA object. Like no other system allows you to do that. So if you like writing like really weird solutions to difficult problems, it's kind of fun. So don't forget that these systems exist. And with that, thank you so much for your time. I hope you enjoy the rest of the workshop.
Does this mean you don't take questions? Or?
Oh yeah, I'll take any questions, sorry.
Where is your?
Well, He's currently watching the first 30 minutes of Cars 2, quietly enjoying a rotten squash. Like, I don't know who's that. He misses his wife dearly. It's very sad, actually. All right.